Hey guys, I am so sorry that I'm not back with you today. I did end up having bronchitis, and the doctor told me I had to stay home for 2 days. So hopefully, I should be back with you guys tomorrow. Um, so by now, hopefully, you have your notes. We're going to talk about change of base today. So on your notes at the top, there's a warm up 4 questions. 1 and 2, you're rewriting. Number 3, you're expanding, which means go from one logarithm to as many as you can. And number 4, you're condensing, which is you are going to go from, in this case, 3, and you want it down to 1 logarithm. Okay, so we can pause the video right now to give you guys time to do those problems if you haven't already. All right, so number 1, you're rewriting log base 2 of 32 equals 5 in exponential form. So you're going from a log to an exponential. So if you remember, we start at the base, which is 2. I go around the world, so I'm going to get 2 to the 5th power equals 32. Okay, and we know that's true. 2 to the 5th equals 32. Number 2, rewrite 5 to the 0 power equals 1 in logarithmic form. You start at the base and end up back on the same side. We go around the world, so I end up with log base 5 of 1 equals 0. Okay. And number 3, so I'm wanting to expand. So if you notice, you've got 7x cubed divided by y. Well, there's 7 times x to the 3rd in that numerator, and then there's the y in the denominator. So the first thing that I need to do is handle the fraction, so the quotient property first. So with that, if you guys remember, quotient property uses subtraction. So I would have log base 2 of 7x cubed minus whatever's on the bottom, log base 2 of y. Okay, so this second piece over here, I think that's pretty good. This first one, we got to do some more work, though. Do you guys see here that this is 7 times x cubed? We need to break that up. The cube is not attached to the 7, it's just the x. So would you agree that this is log base 2 of 7 plus log base 2 of x to the 3rd minus log base 2 of y? So hopefully you guys agree with me. And hopefully you're also saying, hey, Miss Jones, you're not done yet. Did you guys notice this guy right here? Don't we know he can go to the front? Yeah, so I'm going to come over here because I'm running out of room. So I'm going to come up here and I'm going to write my final answer. Log base 2 of 7 plus 3 times log base 2 of x minus log base 2 of y is what you guys should have gotten for number 3. Number 4, we're condensing. So the first thing we need to do is move anything that is in front. So that 2 could go to the power. So that would be log of 6 plus log 2 squared minus log 3. Now, can I combine these? So I got addition in the middle, so that means I want to take this number and multiply them. Well, 2 squared is 4, so would you guys agree that this is really going to be like log of 6 times 4, which is 24, minus log 3? Well, then that would give me log of 24 over 3, which reduces to log 8. Okay, hopefully you guys got that. So recall that the logarithm that has a base of 10 is called our common log. Sorry guys, I'm using my computer to do this, so the handwriting is a little bit off, so hopefully you guys can follow me. Just do the best that you can. So the common log is a base of 10. And remember, I told you that if you have the base of 10, just like in number 4, those logarithms don't have a base listed, so they have a base of 10. The special thing about a base 10 is that you guys can actually put it in the calculator, okay? The logarithm with a base of e remember we said is called the natural log. And if you have a log base e, we don't write log e, we write ln, okay? Most calculators have keys for that as well, okay? So that's kind of, we're going to use those today. So if you don't have a calculator right now, we can pause the video and you guys can sign one out. If you sign mine out, make sure that you put them back and cross your name out. And you also may want to use the sanitizing wipes before you use them too. So pause the video right now if we need to so people can get calculators. Okay, hopefully you guys all have a calculator. So using your calculator, you're going to plug in these 6 problems. Okay, notice that they don't have bases, so that means their base is 10. There's nothing listed, so it's a base of 10, so you can plug that straight in. Okay, so round to the nearest thousandth. Okay, it's 3 decimal places. So take a second, plug those in. We can pause the video here too. Okay, hopefully you guys got these values. So double check what you got. If you didn't get these, let's maybe pause the video again and you can talk to your neighbor. Hopefully your neighbor did. And if you need help with plugging these into your calculator, kind of help each other out. All right, so logarithms with any base other than 10 or e can be written in terms of the common or natural logarithms using a change of base formula. So we said that logarithms can really have any base. You can have a base of 2, you can have a base of 5, you can have any base, but we can only plug base 10 into the calculator to evaluate it. Okay, so I'm telling you that we can use this change of base formula to evaluate logarithms that have bases of 5 or 8 or 12 that are not necessarily in the calculator. So the formula, the way that it's going to work, you have log base b of n, okay? No matter what this base is, if the base is anything other than 10, we can use this formula. Okay, so what you're going to do is you're going to do log of the big number font-wise. This number is not necessarily going to be bigger than the base. It could be smaller. So I always say log of the big number font-wise over log of your base. Notice I didn't write bases here. What do you think I'm going to use as my base? Well, 10, okay? Both of those are going to be base 10 or base E. And if you do base E, then you would actually use ln. You could do ln of the big over ln of the small, okay? And what that's going to do is that's going to let you evaluate logarithms that have a base other than 10. So let's practice some of these, okay? So you know number one says log base 3 of 9. Okay, well, that's saying 3 to what power is 9? You know the answer to that. You know the answer is 2. So let's use our formula, okay, that we just said, and let's see if it works. So the formula is log of the big number, font size, over log of the small. So it would be log 9 over log 3, okay? So plug that in your calculator. When you do that, you need to be careful. When you do log of 9, it opens up parentheses. So after you enter in that 9, you need to close the parentheses, then press your division button, and then do log 3. Otherwise, it's going to evaluate a log within a log, and that's not going to give you the correct answer. So log 9, close the parentheses, divided by log 3. Hopefully you got a 2. Okay? So number 2, log base 6 of 1 over 216. That is 6 to what power is 1 over 216? Well, hopefully you guys are thinking in your heads, okay, 6 cubed is 216, and that's 1 over 216. It's a fraction, so that means it's got to be a negative. So the answer would be negative 3. So let's see if we get that. Okay, remember what I told you, it's log of the big number font-wise, because 1 over 216 is actually smaller than 6, right? But that's what goes in the numerator. So log 1 over 216 over log 6. Okay, make sure you're using parentheses, you're closing those parentheses when you enter these in. Okay, hopefully you guys got -3. Okay, so now we're going to keep going. The next one, log base 16 of 2. 2 is smaller than 16, but again, the bigger font size goes on top. Log 2 over log 16 equals, and you guys should get 0.25. Okay. Number 4, log of 152 over log of 2 equals, and we're going to actually say approximately 7.248. We're going to go 3 decimals. Okay, and anytime you round, we're just going to use we're going to approximate there. So remember, the reason why this works is because we have taken all 4 of those and we've changed them to have a base of 10. Okay, and you could change it to have a base of e by using ln. So like number 4, you would have done ln of 152 over ln of 2 and gotten the same thing. Okay, number 5. This is a special one. Do you remember when we were doing our notes, there were 3 things that I told you that would always be true. I told you something about log of a negative, log of 0, and log of 1. Do anybody remember what log of 1 is always going to be? Hopefully you guys are jumping at the seams to say 0. Okay, so log of 1 is always 0. So if we plug this in, log 1 over log 7, you should get a 0. Okay, so remember, log 1 is equal to 0. Log of 0 and log of a negative, those are always not possible. Okay, so number 6, here we go. So log 0.583 over log of 3. The base goes to the bottom, base to the bottom, base to the bottom. That's another way that you can remember this. All right, so you guys are going to end up getting approximately -0.491. Okay, number 7, log base 17 of 34. We would get log 34 over log 17, base to the bottom. You're going to have to round that. 1.245. Okay. And number 8, log base 25 of -120. I'm not even going to try to plug that in my calculator because what do we know? Log of a negative is always not possible. Okay. So now we are going to condense and then use change of base. Okay. So number 1, I have subtraction. So subtraction goes with the quotient property. So I'm going to have 8 divided by 12. So this would be log base 5. Well, what do you know about 8 over 12? It's going to reduce, isn't it? That reduces to log base 5 of 2/3. So when we plug that in a calculator, we would have log of 2/3 over log 5. So take a second, plug that in, and we should get -0.252. Okay, so again, I've got a negative sign. Negative, that goes with my quotient rule, so I have ln of 16 over 4. That's going to reduce to 4. So I get ln of 4. So is it necessary to use the change of base formula for this problem, or can you plug natural log into the calculator as is? You can plug that in as is. So ln of 4, plug that in, and you should get 1.386. Okay, so remember ln and base 10, that's what your calculator's using. So if you are already in a base of e or a base of 10, then there's no need to use the change of base formula. All right, so jumping ahead, number 3. So I need to move the 2. So condensing means that it's one logarithm, okay, nothing in the front. So I can move that 2 to the exponent, right? That would be log base 3 of 5 squared. Well, log base 3 of 5 squared would be log base 3 of 25. Okay, so using change of base, that would be log 25 over log 3. And that's going to give you 2.930. Okay, number 4. I've got addition in the middle, so when I combine these, I know I'm going to use multiplication. So that's going to be ln of 3 times 1. Well, that's just 3, right? 3 times 1 is 3. ln of 3. That's a base of e. You can plug that straight into your calculator. ln of 3 is going to give you approximately 1.099. Okay, so let's pause the video and you guys take a second and do number 5, 6, 7, and 8. Remember, especially on number 6, you need to move the 2 that's in front, right here. Move that first, then combine. Same thing on number 8. Don't forget to move the 4. Okay, so pause the video and you guys do 5, 6, 7, and 8. Okay, so hopefully you guys finished those. So here's my work for 5, 6, 7, and 8. You can check what you got. Go to number 8 real quick. So you move the 4 and you get 2 to the 4th power. 2 to the 4th power is 16. So then you end up with log base 16 of 16. Then that's log 16 over log 16, which is 1. Well, that makes sense, doesn't it? Same numerator. The numerator and the denominator are the same, right? So that's going to reduce to 1 always. So this is another special thing about logarithms right here. If the base and this number back here are the same, it's always going to equal 1. So log base 16 of 16 is 1. Log base 10 of 10 is 1. Log 97 of 97 is 1. Anytime these numbers are the same, it's going to reduce to 1. So at this time, if you need the video to be paused so you can check these, raise your hand and you guys can pause the video. Otherwise, we're going to keep going. So the bottom section, expand. Okay, so expand means make it bigger, make it more than one logarithm. So number 1, I have log base 2 of 9 times x. Well, multiplication splits into addition. So I get log base 2 of 9 plus log base 2 of x. Okay. Number 2, ln 22 times x. Okay. So what I end up with is ln of 22 plus ln of x. Okay. Number 3, we got a couple things going on. 4 times x to the 5th. The 5th is attached to the x, not the 4, so I break up the multiplication first. So I get log 4 plus, because product property has addition, plus log of x to the 5th. Well, then I can't forget about this guy back here. He can't stay there. He needs to move to the front. So log 4 plus 5 log x. Okay, number 4. I got this power back here. This guy's got to go. 6 moves to the front. I get 6 times log base 6 of x. Okay. Number 5. I've got division going on. Okay, I could break that up. Log base 4. So that's the quotient property. I could break that up into log base 4 of 4 minus log base 4 of 3. Okay, Remember what we said, if the base and this number are the same, it's always going to equal 1. So you want to simplify if you can. So 1 minus log base 4 of 3. You don't have to do anything to the log base 4 of 3 because that would require change of base. So we're not going to make you do that. All right, number 6, log base 3 of 25. Well, it says expand, but I'm thinking maybe there's nothing I could do to that. But we could. Log base 3, could I rewrite 25 as something else? Maybe 5 to the second power. So then I can take my exponent of 2 and move it to the front. So 2 times log base 3 of 5. Okay, so what if that 25 was an 8? Then I could have maybe said 8 is 2 to the third power, right? And then move the exponent to the front. Okay, you guys try number 7 and try number 8. Number 7, there's several things going on in here. And then number 8, you're going to be able to simplify that 64 is going to simplify and reduce. So pause the video and you guys work 7 and 8. All right, and there's my work for number 7 and for number 8. So number 7, you could have broken it down into 3 natural logs. Number 8, remember I told you to be careful with the 64. Log base 8 of 64, that's saying 8 to what power is 64? Well, y'all know that 8 to the second power is 64. Okay, so this becomes a 2, so you always simplify if you can. All right, so those are the notes for today. So hopefully you guys were able to follow along okay. If for some reason you missed something, if you go on YouTube and you search Kelly Jones Math, you'll find this video there, and you guys can go back to it tonight if you need to follow along again if you missed something. So now you guys can work on your homework, and I will see you tomorrow.